Hello students, welcome back to RCC Riaz Classroom Calculations. Myself am Mohammad Riaz. The main aim for creating this YouTube channel is to clear each and every topic for the mechanical engineering students who are studying in both diploma and BTech. In the previous class, I have discussed the subject thermodynamics, and in those lecture I have discussed about the syllabus for the BTech second year first sem mechanical engineering students. Yeah, to be continued in this video lecture. I am discussing about the first unit, that is introduction to thermodynamics. If anyone who does not subscribe, please like and share and subscribe my YouTube channel, and share with your colleagues and friends so that they can gain some good knowledge. Okay, now I am going into the topic. Before going into the topic, for the thermodynamics, the reference books is Pick and Hog, which is a very much important reference book for both concepts and for the problematic point of view. So in this Pick and Hog, we may solve some solid examples so that we can gain some good marks in semester examinations. I have took in RS Kurmi as a second option because this book will give some brief idea for the who is a uh, who is very new into the thermodynamics. This book will give some basic knowledge and basic ideas, and in this book we have some basic problems, so we can also solve this also. The study process is you have to follow my class notes and problems which I will discuss in this YouTube channel only, and after this your duty is to solve some solid examples from these textbooks. Max I will cover all the problems. To be good in this subject, you have also do some solid examples by your own. And the third step is you have to do PYQs of your semester examinations. Okay. Now, introduction to thermodynamics. What is thermodynamics? Thermodynamics is a branch of engineering science and it affects on property of the system. Here he is telling thermodynamics is a branch of engineering science and it affects on properties of the system. Here, 1 minute. Here, the properties of the system, which includes pressure, temperature, volume, enthalpy, entropy, etc. If we change these properties, then we can say that the system which is changes. So the energy transfer may be heat, work, or both. If these properties will change the system, the main effect will be done by the heat or work or both. The main aim of thermodynamics is to convert disorganized form of energy, which is heat, into organized form of energy, that is work, in an efficient manner. Here, the disorganized form of energy is heat. Heat may be in different forms, so we have given it named as a disorganized form. From this heat only we will create the steam, and this steam is used for converting the or to run the turbines. So this disorganized form of energy is converted into the organized form of energy. The main thermodynamic properties are pressure, volume, temperature, enthalpy, entropy, etc. This entropy is very much important. This we will discuss in the second law of thermodynamics. Now, the examples of thermodynamics in daily life. We use the basic concepts of these thermodynamics in refrigeration, that is fridges, either in the car engines, that is internal combustion engines, melting of ice cubes, that is melting of ice cubes, AC air conditioning, steam turbines in power plants, that is turbine compressor, like this, pressure cookers, like all this. We will use this thermodynamics concept either in the jet engines, aeroplanes, all these we will use thermodynamics concept only. Yeah, we have two types of approach in this thermodynamics. One is macroscopic approach and another is microscopic approach. First we will discuss macroscopic approach. This macroscopic approach is also called as classical thermodynamics. In these, the study of behavior of group of molecules as a whole or continuum is considered. Here, if we consider it as a one system, here if you want to measure the temperature in this system, we have to, in this average value is considered in macroscopic approach. That is, if you go on atomic level, the area will be very large. So in those, if we keep on the thermometer here, it will give one value, here it will give another value. But in macroscopic approach, we will consider it as a only one, that is, we will consider all the values to be average taken, so that we will reduce some calculations, we will get easier calculations. So this will tell about the macroscopic approach. In thermodynamics, we will follow this macroscopic approach only. All the pressure, volume, temperature, etc. are measured at the macro level, so that so-called macroscopic properties. Hence, average value of the properties are taken. This is a very much important value. In macroscopic approach, we will consider the values to be average. Continuum concept. It is very important concept. The main definition of the continuum is continuous. Its definition is, it is a idealization where we assume continuous distribution of mass or matter throughout its volume without any gap or void. In continuum concept, matter is assumed to be distributed uniformly and continuously. For applying this continuum concept, there should be large number of molecules, mean free path must be small. Continuum concept is of macroscopic approach. Here, the continuum concept means, if we consider this as a system, for the gases we have the molecules which is distributed very far in liquids and in the gases. For solids, it may be very nearer, but there is a gap. He is saying that the continuously distribution of mass or matter. Here, uh, 1 minute. Here, the matter should be continuously distributed throughout its volume without any gap. This will give the definition of continuum concept. Here, there is no gap. The gap between the each and every molecule is very small, which is less than the system dimensions. This will give about the continuum concept. Yeah, I will tell you in the brief. Here, he is saying that continuous distribution of mass or matter throughout its volume without any gap. Here, we will get the mass or matter without any gap between the atoms. So each and every gap without any volume, without any space between them. In continuum concept, matter is assumed to be distributed uniformly and continuously. For applying this, there should be large number of molecules. 1 minute. The molecules should be very nearer, like this, which is very nearer. Mean free path must be very less. Mean free path means here these are the two molecules. The mean free path must be very small. Mean free path, which is less than this atom dimensions. Continuum concept follows the macroscopic approach, that is average. Now the second approach is microscopic approach, which we call it as a statistical thermodynamics. Study of behavior of individual molecules at micro level, useful at higher altitudes and elementary volumes, etc. Here, that microscopic approach is taken as a average approach. But in this microscopic approach, we will study the each and every molecules and the molecular micro level. We will study this one only. We will study this one only. We will study about this atom, this atom, this atom. But in macroscopic approach, we will take the average of all those atoms. So this example for this microscopic approach is electric tube study, rocket at very high altitude, high vacuum technologies. Thermodynamic system. These are the very important concepts. What is thermodynamic system? It is some region in the space or fixed mass upon which the study is focused. The system, 1 minute. Consider this as a system. It is a region in the space where our focus is maintained. That is called as a system. Here our focus, our main motto is to study this, so we call it as a system. Now the surroundings, anything external to the system is called as a surroundings. System boundary, the separation layer between system and surroundings is called as a system boundary. This is another type of example for the system. Here we call it as a system. Here the whole volume and it is surroundings. Like anything external to the system is called as a surrounding. This is the boundary of the system. Now surroundings, everything external to the system, as I said, is called as a surroundings. Boundary, it is an envelope which separates the system or surroundings. It has zero thickness and does not occupy any volume or mass. As I said, it is as a boundary. There are three types of boundaries: rigid boundary, movable boundary, and flexible boundary. I will discuss each and every one. This is the rigid boundary. The first one is rigid boundary. In this, if we have added some mass or heat if we supply some heat or we added mass, it boundary does not changes, so we call it as a rigid boundary. Now, movable boundary. If we apply pressure, this volume of the system will be changes, so the boundary will be changes, so it is called as a movable boundary. Here, imaginary boundary, consider it as a pipe. If the water is flowing from this area to this area, here if we if we imagine it as a some boundary, actually it is not there, but we are assuming this one, so it is called as a imaginary boundary. This is about some basic concepts of thermodynamics unit 1. Hope you guys will enjoy my video lecture. Please, if anyone who does not have subscribed till now, please like and subscribe and share with your friends so that they can gain some good knowledge. Thank you.